All right, good. Sorry about that. Um, I mixed up your class in period one, and then when I changed the time, I forgot to change AM to PM. So you were showing up at 10:32 p.m. when it was assigned. Um, but that's okay. Uh, Make sure to actually do that if you haven't already. I'll take attendance toward the end of class. Uh, but that is in the end going to be worth a significant amount of points. Right now, I have it in the exam section. So think of right now you just have an automatic 100% in your exam section, which is 20% of your grade. All right. Um, Couple things I want to go over this period. First thing I want to do is to go over like the expectations for this whole remote learning thing, and then I want to actually get started with new content. Um, Before we do that, your tests I will have those in shortly. I've been kind of preparing this more than I have been focusing on grading tests, so those will be in, and I'm also still trying to find a way how to like go over that with you. Um, so they will go in. Just be patient. This whole thing kind of put a wrench in a lot of things, but that's okay. All right. Now, with expectations, this was sent in your email. This was sent to you and your parents, so both of you have it. And I want to quickly kind of go over this. If you haven't read it, you need to, because this is going to be how our day kind of works every class time. All right. Um, First thing you need to do every day at the beginning of class is to log into On Campus, go to assignments, go to the discussion board, uh, and reply just here. That's simple. Just reply here, and you get a point in something, a point or 2 points or whatever, in order to make this worthwhile. Okay. What I don't want is to people just to respond here though, and then go away. All right. So in order to kind of combat that, um, homework will I will tell you the homework later in class. All right, so I'll tell it to you here, and then it'll show up in On Campus actually later in class. So you won't be able to see the homework until like halfway through the class or when I tell you on this. All right, um, but just as kind of like a structure to how the day works. So log into On Campus, reply to the prompt, go to this channel, go to YouTube, start the stream. Usually it'll start within like 5 minutes. If it doesn't for whatever reason, if I'm stuck doing something, I will tell you. But that it should be an expectation that this starts within 5 minutes of when the class actually starts. All right. Um, for now, we will use live the comments that you guys have been posting on. That works pretty well for what we're doing right now. Comments for this though should be specific questions only. So it's fine if like the first thing you do is say, "Hey, what's up?" But after that, as soon as I start the actual lecture portion, I don't want any comments unless it's a question. So long as those questions are specific and they're tied to what we're doing. All right. So I don't want questions like, "No, I don't get this. Where does this apply?" Um, I want questions to be something like, "How did you get blank at this step?" Okay. That'll help me help you guys a lot better. All right. I don't want to be scrolling through the live chat trying to find good questions. I want them to be pretty condensed. So if you want to say something to one another, there will be time for that a little bit later. And I do want that. I think it's good for you guys to actually be able to talk to each other, and we will set that up toward the later end of class. But for now, for this part, keep these specific questions only. My break was great. Um, but just hang on to that. Again, there will be time for that a little bit later. All right. Um, Another thing about questions, I'm not going to answer questions unless I know your name. So if some of you guys have names like crazy YouTube names, whatever, that's fine. Um, if you do and you want to ask a question, just make sure you say your name first. Uh, I'm not going to answer questions unless I know your name. Period. That's it. Uh, I'm going to try and make these streams last a little under 45 minutes. I don't see myself going over that a whole lot. Um, Obviously, that depends on the class. For instance, this one might go just a little bit over, just because we're going over this stuff first. But I don't intend them to last an entire block period. Uh, but yeah, that's about what we're planning. Um, After that, so after the actual like lecture part, uh, what I would like to do is to move all of you guys onto Teams, and I'll host like a call where all of you guys can come in and kind of ask questions one on one. That way, I can help you a little bit easier. All right. So if you need help on a specific problem, you can go to that. You can actually physically write on that, and I can walk you through stuff. Okay. So that'll be like the part where you guys can actually talk to one another, um, and kind of catch up. All right. There will be homework every day. I will grade it. It's obviously going to look a little bit different because of all this. Homework will come in kind of one of two things. It'll either be IXL or it'll be some problems on a worksheet. Tonight, for example, it will be one IXL. And again, I'll help you through that. I'll tell you what it looks like. When it is a worksheet, the easiest thing to do is to probably actually use Teams again. So I'll post it in Teams for you guys. You'll complete it in Teams, and then I will check it in Teams. If that doesn't work for whatever reason, you guys will still submit it in on campus. That way it's all in one place for me, and I don't have to go searching through all my emails and that nonsense. All right. So regardless, it will all be in one place, and it won't come in emails. All right. You will be graded every time we have class. So every time you show up to class, that'll be worth something. All right. Something significant and something beneficial to you guys. You are required to be present. This is required. This lecture is required. And again, I'm going to leverage that because I'm not going to actually tell you the homework until later on. During class, you should be in a space that is good for you guys to learn in. All right. So if you're like in bed right now, that's probably not great. Go to a desk, go to a table, have an area that is good for you guys to learn. All right. I'm okay with you guys listening to music during this, so long as it's not on full blast. Right now, I actually have music going on very, very softly in the background. The reason for that, I don't want you guys to just be watching the lecture. All right, so if you're just watching what I'm writing on screen, you're not getting the entire thing. What I'm saying is also important. Okay. Yes, you should take notes. I don't really care how you do that. I'm guessing that you will probably have to do it in a notebook because you'll be using this to actually get the lecture. Will I check those notes? No, but you need to get them. Okay. The good thing about this too is that you can actually go back and rewatch this. So if you missed part of it or I went too fast on some part, you can go back after we're done with this and kind of look through it. Besides all of that, tests will look different and retakes will look different. I'm guessing that some of you will want to retake the last test. That's fine. I'm still kind of trying to figure out a way to do that. And I'm also trying to figure out a way to actually give tests. What I'm thinking right now is that you guys will actually video yourself doing a problem and explaining every step of that problem. And you'll have like a window to do that in. You'll have a time frame to do that. But that's kind of where I'm leaning right now. I just am not sure how that's going to work with submitting it and all that stuff. So just be patient with that part. And we'll kind of hammer out the details later. If you have one-on-one questions, Teams is the best place to do that. Pretty much all day I'm online and checking my email and checking Teams. So if you have a really quick question, throw it out on Teams and just see if anyone responds. And anyone can respond, even if it's not just me. If you know how to do a problem and someone asks a question, respond to them, help them out. You guys can start calls on your own. You guys can talk each other through problems. In some cases, quicker than I can. So if I'm teaching a class or something and you guys have free periods, start a call and try and work through stuff. That's totally fine. That's what it's there for. A couple of just a couple more quick things. This is not an extended spring break. This is still school. Your parents are still paying for this. So it's like, this is still school. This isn't just nonsense. All right. We're still going to do stuff. We're still going to cover content. We're still preparing you guys for the ACT and all that stuff. If we do homework, would we be able to do it through OneNote? Yeah, that's probably what it's going to end up being. Okay. Um, my point with that extended spring break thing, though, like this is not an extended spring break. This is still going to require effort. Just because you're at home doesn't mean this is going to be easy. It's still going to require you guys to actually put forth the same effort that you would in class. Obviously, it's going to look different. We might be even moving just a little bit slower, but I'm still expecting that same effort. Communication is super super important for this, uh, and especially with you guys as sophomores. Um, you guys have to step up. If you don't understand something, you need to address that right away. Tell me if you don't understand something. Go back and rewatch part of a class if you don't understand something. Go to Teams, start a call if you don't understand something. Email me if you don't understand something. It is super important that you guys do not fall behind, especially in this remote learning context. Okay. I can still help you and I still will help you. It's just a lot harder for me to see when people are struggling because I'm not physically there with you. Okay. Um, we'll get to homework stuff here in a minute. Don't worry about that right now. Okay. Um, different classes will look slightly different. Um, homework will look slightly different. This is all going to be different, and this is all new for everyone. We're all in this kind of same boat where we don't exactly know what's going to happen until it happens. All right. Um, some quick like rules. All right. If you need help and you want to start a call with me, and you're the only one to do that, you need to make sure you're in an open area where like anything can be heard. All right, that's for you and for me, and that's kind of a rule that our admins kind of put on us. Um, there's one more thing. Homework. So if we do a worksheet, uh, and for whatever reason, no, yeah, we're gonna keep it on OneNote just so everything's in the same place. And if that doesn't work, we can change that later. I have ideas about how to change that. My seniors are going to be doing one of those things. Yes, there are consequences for inappropriate behavior, and that's kind of why I'm keeping this chat just to questions, right? Um, obviously, if you act inappropriate in teams, like that's not good, and you shouldn't. Like I can just click people and kick them out of the stream on this. So yes, all right. This list is probably not complete, but these are the guidelines we're going to start with. Okay. And we need to know these so we know what to expect. All right. So our day, just on a daily basis, is going to look like this. You log into On Campus, you reply to the prompt, you go to this channel, we watch the lecture part, then you go to Teams, and then you ask questions with each other, with me, whatever. All right. And I'll show you Teams here toward the end of class. But that's what our day is going to look like. Okay. Um, this stream runs about 10 seconds behind, I think. Okay, so when I say something, about 5 to 10 seconds later, you'll hear it. Okay, that's why I'm going to move just a little bit slower on things that are new, at least. So if you guys have questions, type them out during those like periods of quiet. Okay, that helps you kind of consolidate and helps you get questions. Okay, so with that in mind, are there any questions over any of this on the screen right now? Okay, so for you guys, homework will be submitted in OneNote. So if you have a worksheet or something, you will do that worksheet in OneNote, and then I'll be able to go in your notebook and actually check it. Okay, if it's IXL, that's kind of obvious how that's going to work. Um, if for whatever reason most people don't like OneNote, and I mean most people, like if it's just like one or two or three people, that that's okay. We can handle that. Um, if it's most people though, we'll move to you taking pictures of it or scanning it or doing it as a PDF and then you submitting those things to On Campus. That's what my seniors are doing because their laptops are a little bit less Well, they abuse their laptops for 3 years and they don't have styluses, right? You guys have computers that are pretty capable of doing this even with a finger or another stylus. Like theirs can't quite make that. Your guys, I'm expecting that you can do that. Um, I would email IT probably. Um, Hopefully that's fixed in the next couple of days. Right now, we don't have a worksheet tonight. It's going to be in IXL, so we have a little bit of time. But I would email IT if it keeps not syncing. Okay. All right. So we're gonna kind of shift. So if you have a notebook or something, take it out. Um, and we're gonna start actual like class. All right. Okay. Um, so we've been doing a lot with triangles lately. We're able to classify them. We can classify them by sides. They can be equilateral. They can be isosceles. They can be scalene. We can classify them by angles. They can be right triangles. They can be obtuse triangles. They can be acute triangles, and then they can be equiangular. All right. We've proved congruence of two triangles using side, side, side. We've done the same thing with side, angle, side. We've done angle, side, angle, and angle, angle, side. We've also proved similarity, which is the thing that we just finished. And we can prove similarity of two triangles by three sides of one triangle being proportional to three sides of another. We've proved that two triangles are similar if two sides and the included angle are proportional to two sides of an included angle of another. And then if two angles of one triangle are congruent to two angles of another, then those two triangles are congruent. So this in red, blue, and green is really what we've been working on pretty much this semester. Okay. That's what the last test was over, and even the test before that. And then within that month or so, um, we've also covered the Pythagorean theorem. Okay. So if we have a triangle that is a right triangle, the biggest side, that's always going to be our C side. That's our hypotenuse. That is also the side opposite the right angle. And the other two sides are A and B. Okay. If we have a right triangle and all the lengths are set up like that, um, then our distances A squared plus B squared will always equal C squared. Okay. We've also dealt with proportions and radicals. All right. So we've gone over stuff like simplifying the square root of 12, right? If your screen turns blurry, just reload. This is all being streamed in HD, so it should still be there, right? Um, so square root of 12, right? We have a couple of rules for radicals. We can rewrite radicals as factors of one another. Okay, so we can rewrite this as the square root of 4 times the square root of 3, where the square root of 4 is just 2, and the square root of 3 can't be simplified, so it stays there. Okay. That's kind of, I just want to review that real quick. So this is everything we've done over the last semester. Okay. And what we're going to do for the next couple of weeks, and I don't expect this to take too long, is we're going to focus on right triangles. All right. So with right triangles, we're also going to be working with Pythagorean theorem, which means we're also going to be working with the distance formula. a little bit as well, right? Because these two things, the distance formula and the Pythagorean theorem, can be derived from each other, right? Um, so again, we're just focused on right triangles for this next couple of weeks. Right? Are there any questions about anything on the screen so far? All right. So right triangles. Um, One, you need to know what a right triangle is, and a right triangle is always a triangle with one right angle. Okay, so say we have this triangle right here. From this diagram, we should be able to tell immediately what the hypotenuse is. Okay, and the hypotenuse is always the longest side and the side opposite the right angle. Okay, so this side right here, that's called hypotenuse. Easy. Okay, so that's just a terminology type thing. We need to know that the longest side of a triangle is the hypotenuse, as well as the side opposite the right angle. Yeah, this is kind of new stuff. All right. Now, what we're going to be working with is relationships between angles and sides. All right. So we're going to use the angle theta, which is just kind of like the angle form of x. All right. So when we talk about theta, we're talking about some angle that we don't know. All right. When we have this angle theta, the side attached to the angle that is not the hypotenuse, that's called the adjacent side. The side opposite this angle is called the opposite side. Okay, so if I draw a triangle for you, if I draw a right triangle for you, you should be able to um, give me the opposite side, the adjacent side, and the hypotenuse. That's it. You're just giving names to different sides of angles, different sides of a right triangle. Okay. Now, these angles have different relationships with these sides. Okay. Um, so there are three functions that we need to know. We need to know sine of theta. We need to know cosine of theta. And we need to know tangent of theta. Okay, and each of these functions are just ratios of different sides. So the sine function, so the sine of this angle theta, is always the opposite side over the hypotenuse. The cosine of the angle theta is always going to be the adjacent side over the hypotenuse. And the tangent is always going to be the opposite over the adjacent. Okay, so those three ratios we need to know. So sine is always opposite over hypotenuse, cosine is always adjacent over hypotenuse, and tangent is always opposite over adjacent. And these work because this angle, and the right angle, they kind of determine the relationships of the other three sides. That's why that works. And there's a whole like history behind these things, but right now I just want you to know these three functions. Okay, you may have also heard SOHCAHTOA. And that just stands for sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay, so you can remember it in one of two ways. You can remember it by the diagram, which I strongly suggest you still do this because it's helpful to know what side is opposite an angle and what side is adjacent to an angle. But it's always helpful to know this little SOHCAHTOA. All right, so that's what we're going to be working with, this and the Pythagorean theorem. So keep in mind that with the Pythagorean theorem, the opposite squared plus the adjacent squared is always going to equal the hypotenuse squared. So that relationship still exists. Okay, so this is where we're working from for today, and we're going to practice this quite a bit because this is super important. This shows up a lot on the ACT, so we're going to kind of drill this for a little while. All right. Now, I have two sets of practice problems in on campus, and it's in topics. It's in the new topic. It's in I forgot what I named it. It is right triangle trig, and if you go to right triangle trig, there are two different sets of practice problems. There's trig ratios practice and trig ratios harder. Trig ratios practice, we're going to do one of those, and then I'll show you one of the harder ones. Okay, so this is number 1 on that first handout. All right, and it's asking you to find the sine of x, where x is this angle right here. And these triangles can be in different orientations, but we still have to be able to find the adjacent side, the hypotenuse, and the opposite side. All right, so sine, if we scroll back up, we know that sine is the opposite side over the adjacent side, or over the hypotenuse side. So we need to find the opposite side. And we're talking about x. So we're talking about this angle right here. The side opposite that angle is 7. And I guess I should have made this blue. Just pretend that that was blue the entire time. Okay, so sine of x will equal the opposite side, which is 7, over the hypotenuse, which is the side opposite the right angle, and also the longest side. So sine of x in this case is just 7 over 25. And that's it. That's your answer. Okay. Are there questions about that? So, okay. 25 is our hypotenuse. All right, so sine is always opposite over the hypotenuse. Okay, 7 is the opposite side, 25 is the hypotenuse, so it's 7 over 25. Now, the slightly harder section. So this is kind of an easy example. This example just requires you to know how to identify the opposite side, the adjacent side, and the hypotenuse, and then put it into SOHCAHTOA. That's it. You're just pulling numbers and then putting them in a fraction, so long as you pick those numbers correctly. Okay. A little bit harder example is when, one, we're dealing with radicals, and two, well, yeah, let's just deal with radicals right now. So this is number 12 on the harder exam, on the harder practice. And that gives you this diagram. All right, and it's asking you to find the cosine of theta. Okay. Now, from SOHCAHTOA, we know that cosine is the adjacent side over the hypotenuse. Okay. The adjacent side is the side attached to the angle theta that is not the hypotenuse. All right. So 24 is our adjacent side. The hypotenuse is always opposite the right angle. So it's 12 root 5. Okay. Now, so far this is correct, but in IXL, and really in any test or any standardized test, or really any test that I give you, so ever, this is not an entirely correct answer, because this is not what we call rational. Because it has a square root in the denominator. All right. So in order to rationalize it, in order to get the square root out of the denominator, we have to multiply by something in order to get that square root out of the denominator. Okay. So to do that, we have to multiply by a clever form of 1, because we can only multiply 1 to keep things the same. All right. So that clever form in this case is just the square root of 5 over the square root of 5. Because when you multiply the square root of 5 by itself, that just becomes 5. All right, so this becomes 24 root 5 in the numerator and 12 times 5 in the denominator. Because again, square root of 5 times square root of 5 is just 5. All right, so then our answer is 24 root 5 over 60. And then we can just reduce this. We can just simplify it. So really, you just ignore the square root of 5 for a minute. We can take 2's out, so this becomes 12 root 5 over 30, which then becomes 6 root 5 over 15, which then becomes 2 root 5 over 5. And then this fully reduced and rational answer, that's your final answer. Okay, so this is what would happen. This is what would go in your final answer of a test or an IXL. Okay. Questions about this harder example? Okay. I think that's about as far as the IXL goes. There is another type of question. So does square root 5 have to be at the top 100% of the time? Not necessarily. There just can't be a square root in the denominator. For something to be rational, there cannot be a square root in the denominator. It has to be, if there is one, it has to be in the numerator. All right. The only other type of question that would happen is that instead of giving you explicit the adjacent and the hypotenuse in this case, I might give you the opposite side instead and still ask you to find cosine. So if I were to give you just the opposite side and the hypotenuse and not the adjacent side, we would have to find the adjacent side by using the Pythagorean theorem. All right. I don't think the IXL does that. I looked through all their problems, and if it does, it doesn't show up until like the late 90s. Okay. So I'm just going to hold off on that for the sake of time. And if we need to practice it a little bit more, we can. But for now, what I'd like to do is for everyone to move to Teams. I'll start a call just so you can see it. And if you have any questions over the IXL, so I guess I should explain that too. Your homework, which should show up. If it doesn't, that means your time's off. Or at least I didn't change your time to when it actually is R1. And I'm going to double check that real quick. Yeah, it's R1 in geometry. And that is going to be graded up into 100. Again, if people really don't know how to do it past like 70, we'll hold off there and then we'll finish it later. But we should be able to get very, very far. In fact, really, you should be able to get to 100 because you know the Pythagorean theorem. But I'm not going to hold that against you. All right. So what I'd like you to do now is to go ahead and move to Teams. I'll start a call and I'll just show you what it's about. But again, your homework is R1, and that is, as of right now, due on Friday. Okay. So I'm going to stop this stream, go ahead and go to Teams, and then I'll start a call. All right. Questions about anything I said before I actually close it? it allows as many people as I want there to be. So I'll start one and I'll show you. Okay. So I'm gonna hop off and then I'll be there in like 2 minutes.